recording. I thought it would be the ant, but it was the planet the whole time. So yeah. Hello. Glad you're here. So let me get rid of this dorky little thing. And remember what question that was? Okay, so back to, oh, there you go. So I call it the ant problem because it was something similar with the ant walking around on a hot plate or something. But this one, I guess, is just the planet, blah, 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 heat something. Okay, so yeah, let's do it. I'm super excited to do it. Positive thinking, right, guys? Um, so we have an ellipsoid, planet's atmosphere. After 1 hour, we have the surface. Find the hottest point on the probe surface. Oh, that's the temperature. Oh, the temperature. Okay. Man, y'all are gonna make me have to work hard on this one because I can't remember now. I think that we're gonna have to do. Oh, okay. Yeah. Got it. This is Lagrange stuff, right? Okay, yeah. This is easy then. No, I'm gonna say it's not easy. It's not easy, but we could do this. So we got grad f is equal to lambda grad g such that g is equal to 0, essentially. What we want to do is first off find what f and g are. We're trying to minimize or maximize. I think it's minimize, maximize the f part. And it says what's the maximum temperature. So this will be my f, and this would be my g. Okay. So let's do some grad f business. Technically grad t, because that's cap t. So derivative in terms of x. Oh, thank you. And then that's it for y. And that's it. And then for z. Okay. Grad g. So again, just move this over. It wouldn't really matter. Anyways, derivative in terms of x. X, 2y, 8z. Thank you. And so I'm saying that 144x is equal to lambda times 72x. Like, because, I'm doing like pairs, basically. This one's the most obvious to me. Couldn't I just divide by 72x on both sides? So lambda would be equal to 2? Oh, yeah, because there's 72 right there. Look at that, 2. Yay! Doo-doo-doo! And that's super awesome. I feel like you've done this one before. Okay, good. It helps to have done it, yeah. I could see that. So then I can go back and say the other one. So I got 4z is equal to 2 times 2y. And then I got 4y minus 16 is equal to 2 times the 8z. Again, I'm using 2 because that's my lambda. Right there, that's my lambda. That's my lambda. And then I can start solving. So 4z is equal to 4y. I mean, to me, it sounds like y equals that, or y equals z. Am I right about that? Okay, cool. And so if that's the case, then I just need to solve for either one of them, I suppose. Like this one here would help me with that. So here I have 16. Sorry, I'm blinking out a little bit. Minus 4 on both sides, so that would be 12 now. So 12y is equal to negative 16. Y then would equal negative 4 over 3, essentially. And therefore, z also equals that. And then x. Oh, I'd have to go back and plug it in up here. So then 36 x squared plus 4/3 squared plus 4 times 4/3 squared. I mean, is this looking right to y'all? The 4/3? Oh, okay. I mean, this is Stump the Professor Day. Days. So I've got 5 times all this stuff and blah, 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 calculator. Yay, calculator time. Where's my calculator? Give me a calculator. Like literally, where okay, I'll just do this. Calculator time. Da, 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 da. Yeah, but when you square it, I'm just one of those super lazy professors. You've seen them around campus, they like wear flip flops and like cut off blue jeans and stuff. Yeah, that's me all day long, right? Yeah, yeah, flip flops, exactly. That's what I do around here. Good thing they haven't fired me yet for that, because that's totally breaking dress code. We don't have that here. Okay. And so we have x squared is equal to that, and that's probably why they have a plus or minus for your answer there. So I'm going to do the square root of answer, and perfect. That looks great. Okay. Blah, blah, blah. I plug it in. We get some numbers. Let me go back to my homework. No, this is the exam. I'm sorry, the practice quiz. This is a practice quiz. I want to submit it. Are y'all okay with me submitting it? I don't know. Oh, it was like almost the last one there. Submit. Yay. Did I get it right? I got 1%. Yay. Okay. No, yes. When I had this, I plugged them in to that one, and then I got this guy. Do you want me to pull it back up? Okay. Desmos? Like this stuff? I plugged it in here to this thing up here. The ellipsoid. Because it has the equal sign. Meaning like it's a constraint. Yeah, that's definitely a possibility on the exam. What? Yeah. Yeah, if it's equal to some kind of like a number or a function or something like that. But the other one, it has an equal sign, but it's like t equals, right? That doesn't really qualify. This is an equation. That's just a function. Yeah. Yep. Cool. Good. So then, back to 15. Unless y'all had something else for me here. Y'all come first. Okay. Cool. I did send out a list yesterday on Blackboard with the formulas you need. It's not the same. Here, I'm going to pull it up. It's not the same as saying these are the questions on there. It was just what formulas did I think that would be helpful to have. Now, they almost all correlate, right? If I say, hey, you need directional derivative, you'll have a question about directional derivative, if you, oh, I forgot to write Lagrange on there. Like, is that a formula? Well, then I guess I can add it right now. So, yeah, formulas, and I'm going to edit content, and I'm going to add Lagrange here. I don't know. Where do you want me to put it? Right here. And unless I already had it somewhere, Lagrange multipliers, formulas. Now that's fine. Anyway, so I posted this. It's just a short list of stuff. Like in particular, right here, how many times have we done integral of cosine or sine squared? But also the cube just in case, okay? Which is the n formula technically. It's just integration by parts. So this one's technically easier than this one, but either way. So yeah, that's just a list. It's kind of small. Is that okay? Cool. But we're gonna still see as we go through, of course. So let's keep going, and I'm gonna say yay or nay as we go. I forgot my list upstairs. It's okay. I've memorized the whole thing. Doubtful, Chad. That is so funny. No. What if I'm wrong on one little thing, and then No.
When I did computer for the formula sheets that the what the formulas you told us to have, can you reference that if you need to?
Say that again.
The formula sheet that formulas they told us to have on Blackboard.
Yeah.
Could you reference that? Okay.
I mean, it's not a. And said, "Oh, I would need that or this." So, and there's a good example here of one of them in particular coming up. These are all we've already talked about these. I know here this one. So I was thinking to myself, oh no, they're going to need to know the arctangent integral to get to arctangent kind of thing, because see x squared plus 1 in the bottom. No, because there's an x in the top. So that's when I wrote u sub. Right, that says u sub is what that one is. Sorry. We're good. So that kind of thing. Did we do any of these?
Not yesterday.
Okay. Then let's do it. Are y'all okay with these little integrals though? Right? I mean, those are not hard at all. Even that one, that's really not that bad. But this one here is interesting. So find the volume above and below. Oh man, look at this. I'm just going to set it up. I'm not going to actually do it because I feel like it would waste your time. But I could definitely set it up here. So we're finding the volume. You can do triple integral if you like, or you could just say top, bottom, down here. So it's above by this much and below by the plane, essentially. It's like minus 0, essentially. It's like this minus that, top minus bottom. Or you could do a triple integral is fine too, of course. Negative 4 to 4. Negative 4 to 4. Are we okay with that one? Right, it's kind of just like, set it up. And then y'all just integrate it. So in a way, I'm looking for like the harder ones.
And with that one, Chad, since it had.
Yeah, go ahead. Oh yeah, I can hang out.
So with this one, Chad.
Yeah.
Can we since it's the same numbers on top and bottom, but just minus since negative 4 to 4, can you pull that out and do a multiply by 2 with this one?
I would say multiply by 4 if you're going to do that. Maybe they're not. I mean, they're not perfectly symmetric. I know that we have the squares, so I'm hopeful for it. But I would say it's easier just to do it without, instead of possibly getting it wrong. Okay. Yeah, on a safety precaution for something especially so easy, I would just do it. Spend the extra minute. Just my recommendation. Good? Like, I'm not doing it unless y'all want me to do it. I just don't think that one's worth your time. Oh, okay, then you're good. So I can keep cruising. Same thing here. No problem there. Yep. I mean, as long as I see these regions are basically rectangles and there's nothing like totally crazy going on, these are all just simple double integrals here. Yeah, all this is definitely possible on the test. Double integral has a little function. Oh no, we have never seen that one before. I'm playing like we did way crazier than that so far. E and ln are going to cancel, so I'm not worried about this. Are y'all okay with these so far? Because I could stop at any moment.
These are just the ones where it just wants you to integrate the problem, right? Not like
Yeah.
rearrange it.
Correct. They would say reverse blah blah blah, and that will come up eventually.
Yeah, that's the one I would kind of like to review.
Definitely. Yeah, right here. Look, does it say it right here? Reverse blah blah blah. Get out of the way, man. Right there. Yes. Okay. Yeah, that's a good one. So I'm actually not going to do what they want. You don't have to do it, do you? Does it? Oh, you do have to fill it in. Oh, boo. Okay, yeah, let's do it. So let me just clear this up, and yeah. So what I have is x is equal to -2, x is equal to 2, y is equal to 0, and y is equal to 4 minus 2x. These right here alone tell a big story. So going up 4, and then a slope of -2, down 1. So essentially like here and here.
Draw a line. There you go. And then we're going from -2 to 2, which means it's actually going to go like way out here. Down to like right there. So there's my triangle. So, which one? A, B, C, or D? It's hard to see, Chad. I think A. You're right. I'm looking more at the bottom. See how it goes from -2 to +2 right here?
Oh, right, and it crosses through the Y.
Yeah.
I was thinking it ended at Y.
Right. So, yep, I'm thinking this guy for sure. And then now I have to reverse it. So, what I want to do is get like basically this one reversed. So, move this guy over, and then I'm going to divide by the -2. So y minus 4 divided by -2. If you want to make it look pretty, plus 2, I guess. So that's the big one. That's an x equals. I think what we're gonna do, I think it's gonna be -2 to this guy. I'll explain here in a second, and then my y's are gonna go from 0 all the way to 8, like you were saying. 8 is way up here. So I'm going from left to right, and so this is my left and this is my right, and that's why I went from -2 to the line. Cool. They don't want you to actually do it, which makes me wonder if it's on the test. So order later. Sorry, guys. Allergies. Like my kids have been snotting so much. It's crazy. Every night I can't even breathe. It's just crazy. But you just keep going. Positive thoughts. Yeah, it lasts for like a week or two in Texas. Then it's summer. Same stuff here. Again, just do the stuff. I'm not worried. Are y'all okay with that? I'm looking for hard stuff. This one?
Not that one in particular, but similar.
This guy?
That guy.
Let's do it. If you say so, I'll do it. Thank you. So I got x is equal to e to the y. X is equal to 2. Y is equal to 0. Y is equal to ln of 2. So first off, when I do this thing here, I'm going to ln both sides. So ln of x is equal to y. Doesn't that look suspicious right here? Look at this. Just saying. Kind of interesting how that all works out. You don't have to know that to get the right answer, though. I was just playing around with my math. So this is what I'm probably going to start using here in a second. But let's draw this so I can make sure I'm doing it right. I have e to the y. So that's this guy right here. That's just ln. So there's my ln. Y equals 0. X is equal to 2. I think that would be somewhere over here. Well, there you go. I guess that's it. There's my area. Yay! So A, B, C, or D? I would hope so. So then I'm now going to go to dy dx, which is easier. This is top and bottom. So on the bottom, I have a 0, and on the top, I have that ln. You got it. Now, for x, I'm starting here, and then I'm going to go to 2. Where does ln cross the axis? At 1, very good, always. And it's not the scale, sorry. But you're exactly right. 1 to 2. Cool. Happy times. Positive thinking. That's my thing for the day.
We need to get you one of those motivational posters, stick it right over there. Like Adam says being in there. Yep.
Oh, that yeah. The are y'all good with this? You're good. Okay. There was one upstairs where it was like the Great Wall of China. It was like something like teamwork. And I was thinking it's like, wow, you know how many people died making that thing? Like, okay, that's right, teamwork. Anyways, is this just reverse it again? So we would end up with the square root, but I'm not that concerned about it. Are you good with that? I'm gonna keep going. Yada yada yada. Same thing, same thing. So you'll end up with square root of 16 minus x squared. That's really all it comes down to. Okay. E and ln? Do you want me to do it? Yes or no?
Sure.
Okay. You mentioned E and ln, so now I'm here. Oops. So I have y is equal to 0, y is equal to ln x, x is equal to 1, x is equal to e. So ln of x, 0, x is equal to 1, and then x is equal to e, which is 2.7 basically. I mean, to me it looks like the same thing as last time essentially. But because we're going the other way, I would now have to say that x is equal to e to the y. So I'm starting with left and right. So this is on the left side, and this is on the right side. So on the left side is e to the y. And on the right side is e. Like to the 1, I guess. And then now I'm doing top and bottom. Bottom, 0. Top. Where does it go to right here? What's ln of e? 1 again, yeah. I hope. I hope. We're going to see when I submit it. It's a little weird. That okay? If y'all got something, tell me. Keep cruising then. More ease? You eat out?
I think I roughly understand now.
Okay. Keep cruising. Ah, we did this one last time, but I didn't do it on the recording. Would you like me to do it now? Okay, let's do it. So what happened was it looks funky, and I got scared because I don't know how to integrate that. It looks like it's 1, right? That's the idea, is that it looks like it's 1. But they say do it by reversing the limits and all that kind of stuff. And then we have to find it. Okay, yeah. And this is on there for sure. So the idea is that we need to change this so that I have a dx dy. And I hope that we can do that. The first integral is super easy because you just put an x in there. But then I need to know from what to what. Like, what's the integral in terms of x? It's x times whatever, right? So let's go and find those limits and stuff. Like, because right now I just stopped. I can't go any further until I do the I guess, looking at it. So I got y equals x, I got y equals pi, x is equal to 0, x is equal to pi. And when I graph y equals x, it's just a 45-degree line. Y equals pi, it's right here. And then x is 0, x is pi. Basically, it's this little zone in there. So on my original over here, let me use a different color for a second. I'm again wanting to do left and right, and this is bottom and top. But now, okay, yeah, that's exactly right. So on the left side, I have 0. And on the right side, I have the line. So y equals x, but x equals y. Top and bottom. So top is pi, and the bottom, again, just numerics would be a 0. But we can probably already see that from last time. It's basically the same thing. So I take this y, I plug it in, the 0 would cancel. So then we got y sine of y over y. And then that's how you do the rest of it. Because now it's super easy. Let me do this. Okay. Because it was getting a little squished. 0 to pi of sine. So negative cosine of y, 0 to pi. When you plug in a pi, you get negative 1. 2 negatives make a positive. Regular 1. So 2. Cool. We did it. We did it. Da, 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 da. Da, da, da. Is that okay? Positive thoughts. No, positive thoughts. It's a great problem for an exam.
Yeah. I would love it if that was on my exam, especially seeing all the names.
Yes. That's hilarious. See, that's a positive thought right there. Makes me feel good. Yeah, I already know the answer. See? Yeah, you know the classic C Blue Book. Gosh, man. I had someone in calculus that did that for every question, and they made a 0 in like WebAssign. If y'all know WebAssign, so they made a 0, and I was so upset. Like, really? So I went, and did it. I looked through it all, but yeah, I yelled at that person. No. I had a nice discussion. Positive thoughts today. Positive thoughts. Had a nice discussion with that person about next time you will fail. I'll leave the 0. Anyways, find the volume by this and that. I mean, I can do it if you like, or I can keep going. It's just a double integral yet again. Exactly. Yep, just double integral stuff again. Same thing here. There's your z on the top, bounded by that.
So
Go ahead.
X on that one, we just have to set the y is equal to 0 and then solve for x.
Yeah, you can do that.
So one thing is, you can actually, can you technically treat that as a triple integral just because
Oh, always. Always, yeah. You can always do triple integral. Like, yeah. I should be teaching that. I should be saying triple integral. Cut from the first octant. Oh, first octant. So then you're just going to have 0 to something, 0 to something. I want to show you how to maybe to do this one. It's not the 0 part that I'm nervous about. I'm not nervous at all. Positive thoughts. So we got z is equal to all this business here. But what happens on the xy plane is that this makes it this equal to 0. And then I solve for y. And so what's happening is that I have this 18y 2x squared dy dx from 0 to now 18 minus 2x squared. Well, what if I got rid of the y and then I need to solve for x? So then I move that over. So 2x squared is equal to 18, x squared is equal to 9, plus or minus 3. That's that dimensional reduction stuff where I'm just I'm setting it equal to 0 one at a time and going all the way down. Now, to integrate this thing, it's not terrible, but it's a little long. So I just want to, what's up? Oh, first octant. You're right. They said octant. Thank you. I was trying to be good. And then I went bad. Positive thoughts. That's right. No, you know what? I was wrong, but you were here to help me. Just like when I'm taking the test, you're there to help. When you're taking a test, I'm upstairs. But as you know, that's why we have Blue Book stuff, because I'm going to look for that stuff. Here, it would be off, and I would say, why is it off? And I'd eventually find out why. Good? You want me to actually integrate it, or because it'll take forever? It's polynomial, but it's just kind of meh. It is. It's not a happy one, but are we good concept wise? Keep cruising. We can always come back to whatever you want to, of course. Wedge, first octant, cylinder, and the plane. So the plane is the giveaway because it's y equals 2 minus x. And so first octant, definitely zeros, 2 minus x. And then if you got rid of your y, x would equal 2. So no big deal here. See, I'm not worried about that one either. Okay, cool. Okay, I can hold. I can hold. Happy days in math class. Ba-da-bum-bum-ba-dum-bum. Just think, y'all are at the tippy top. You don't have to come back again. No more calculus. They don't offer calculus over there in TAMU CT or anything. So, I don't think you'll ever see it again. Really? Well, I mean, you will. Yeah. If you're an engineer. And I guess in math, we'll have it. It'll come up once in a while. Definitely not that. But they'll say, oh, for statistics, just integrate from negative infinity to positive infinity, blah, blah. And you're like, I know how to do that. But then you don't really have to do that because it's not really an integral anymore. Okay, good? Okay, cool. Oh, with the infinity. Yeah, y'all are fine. Let's keep going. You want me to do it?
Sure.
Oh, okay. One yes means a yes. I'm okay with that. Me neither. I just wing it. This is Stump the Professor Day.
Oh wait, since we have
Then you will be caught cheating and you get a 0.
maybe to the negative x, wouldn't that infinity eventually just end up going to 0?
I don't know yet, but that's the idea. We will get a finite number, I believe. So in terms of y, I got y to the negative 1 essentially. No. You know what? I don't like what I'm doing here. This is way dumb. Let's do this instead. Is that better? I like that one better. So I add 1 to the power and divide by a new power. Oh no. I can't divide by 0, so therefore what am I actually getting is a ln. There it is. That was perfect. Thank you. Exactly. It's one of those I'm stuck and I don't know what to do. And that's proving that it's the ln because it's not a normal polynomial stuff thing anymore. I say polynomial, I just mean p power n and p series, whatever. Moving on. Plugging in the 1, ln of 1 is a yes. And then we plug in e and ln cancel to make, yep. Oh yeah, because 2 negatives make a positive. You're right. A positive x. And then still times this thing, dx. So this is a 1 power, essentially, because we don't need any of that. 1 power and the negative 3 makes it a negative 2. Add 1 to the power, divide by the new to power. I think it's better in fraction mode. So what's actually going on is that we have this guy. And I'm going to plug in infinity and 9. So I got negative 1 over infinity minus 1 over 9. But 1 over infinity is perfect. 2 negatives make a positive 1/9. We're done. Cool. We love this 1 over infinity equals 0 stuff. Who in here does the limit anymore? Okay, good with that though? Yeah?
Yeah.
Infinities. They're fun. Same stuff. I don't see anything in particular here. Sine and cosine? Oh no. I mean, it's easy. I don't know. I don't see anything crazy here. This one looks interesting. Polar integral. Ooh. So we have to put it all in. What goes right here? R. Well, you got 1/4 of it without doing any math. Yay! And you know it's always 0 to 2 pi, right? Isn't that how it's not really that way. I'm sorry. It's not that way. But that's a good guess. Yeah.
Was it what's the Steve Harvey show? Yeah, that's what I'm thinking.
So we have a. Oh, okay. I don't know. So yeah, positive only. See, it's going from 0 to a positive only, and then that's where they got the negative 16 to 16 kind of stuff. So I'm actually only going to pi in this case, aren't I? So 0 to pi, and then I'm going to go 0 to the radius. What's the radius for this? 16, exactly. R dr d theta, and then that's super easy to integrate, so I'm not worried about it. Polar is my friend. We hang out on the weekends. Da da da. It's good they're not recording me dancing. Like this, I would get more views. This like aging 40-year-old balding man doing a little, jig. A selfie stick?
Yeah.
Thanks. Anyways, no, I would get more views on TikTok that way, and they'll be laughing at me. Yeah. Anyways, so what would now be this guy? Cubed. Very good, because you had the 1r and then 2 more. I was thinking r squared also. Yeah. But other than that, I mean, positives, this is just a quadrant 1. So 0 to pi over 2, basically. What would my radius be? Easy. All right. Keep cruising. Just trying to look for something a little bit more difficult here. Same thing. What does it say? X equals y, right? Y equals x, the line. Y equals x. So how much do we got? 45. Oh, there it is. Pi over 4. I'll let y'all figure it out. It's fine. It's not hard. Whoa, dude, that's way crazy. Actually, it does kind of look weird. Do you want me to do it? Okay, let's do it. So I'm going to write down some of my limits I have here. I got y is equal to negative, and then I have a 0, and I have a negative 1, and I have a 0. So it's basically on the bottom, but then x is equal to negative 1 all the way to 0. So it's only this quadrant 3 stuff where they're both negative. So if I have to do this, it already has a pi there for me. So pi until perfect. And it already has a 0. My radius would then be 1. Very good. The interesting part is this thing, right? I'm going to just do a direct copy paste because I know that that's R. This whole big thing just turns into an R. And then we have the required R. And I am not simplifying it. The integral for this is, it's a little odd. I mean, it's something you've done a lot, but if you want me to do it, I can. One yes means a yes, I can do it. Yes? Okay. So, let me get a little thinner here. So, I'm a little concerned in the end, but it's really not too bad. This is what we're looking at here. If I do a U sub for the bottom, right? It kind of looks meaningless and pointless. But you can say now that R is equal to U minus 1. That's the trick here. You did a U sub, but to do that part. So you can replace the top and then have a simple bottom. And because I have a simple bottom, I can split it up. So now I have two separate ones. So 2U over U minus 2 over U. And of course the U's cancel. So I got 2 minus 2 over U. And each of those are easy to integrate. Is that making sense, like why I did the U sub? To plug it into the top differently? We've done it before, it's just been a long time, right? That's an ln, isn't it? R equals 0. R equals 1. So this is where I plug it back in because that's who I am. And I would say something like, well, the next teacher might not do it, or blah, 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 blah. What's the next teacher? you don't got one. You're done after this. Isn't that so cool? So plug it in here. Plug it into 1. I got, 4, I guess? Plug it in 1, I got ooh. It's kind of 0, I would get a 2. And 0, I would get a 0, technically, because ln of 1 is a 0. So 2 minus 2 ln of 2. D theta. I would just stop here, but I'm so close to the end anyways. Oh, like at this point? Right, it is weird. All of this is just a big number. I don't know what kind of number, it's just a number. So then my integral is all that craziness just with a theta. Yeah, it's almost like too easy. And then I'm going to just plug in my pi and my 3 pi over 2. And so, yeah, I just keep this weird, crazy scalar thing in the front all the time. But times, now I'm going to do 3 pi over 2 minus pi. So it's going to be like pi over 2, essentially. So yeah, crazy, weird scalar thingy in the front times basically, well, I wonder it should take this. Should. And if not, then you send it to me and I start yelling at people. Thank you, Ryan. It's funny when you do ask instructor with something like that, they don't see, y'all have asked the instructor, I have asked the publisher. And so that's what I was about to send it off to the rep and say, like, how do I fix these things? And I saw that button, I clicked it and said, I basically copy pasted what you had sent me. And they got back with me. They said, oh, we got a case number for you. We're looking into it. And they sent me something. I had to come to class, so I couldn't read it. So, yeah, that was actually kind of cool to see how fast they responded. It was like 3 emails like this morning, so that's good. Well, the best thing is you send it to me. That way I literally just click the button and I send it off. So that's nice. Okay, cool. Making sense overall?
Yeah.
Not too bad in the end. And we got plenty of time. Plenty of time. Positive thoughts. Oh no, it looks so crazy. But it's not, is it? Like, basically, that's e to the r. And I'm thinking that this guy right here, that's my radius, isn't it? So I would say that's very similar. And if you want me to come back and do it, I can. I just want to see what else we got. Is that okay? And I don't mind coming back. Oh, this is not on there. I was gonna have this on there, but I can't. If I can't graph it, then I don't know what to do. So I just deleted that one. Okay. So anything that has like the polar curves, I love them, but we just can't. We can't graph them, so I can't trust myself. Okay. Same thing. Off. No, not there. Yeah, gone. Yeah, and I'm not trustworthy myself enough to do it, so I'm not gonna lay that burden on you. So none of those are on there simply because we don't have Desmos graphing, and it's just a nightmare to try to do that. It might, but the hard thing is I want to bring those in, so it possibly, but probably not. Possibly, but probably not. I'll probably forget, essentially. Yeah, this is super easy. Just, basic triple integrals. So that's definitely on there for sure, because I got to have a basic triple integral. Basic stuff, not worried about it. I think there was one that I had to delete at one point, but you could switch to polar if you want to, because it's funny, but wouldn't really matter. Same thing. See the dimensional reduction part? See that? There's a 1 there. I think that's odd. It should be a 3, but whatever. You just do what they do. Easy. Yet again. This one. It was on there, and I can't remember if I left it because it was good, and I figured out a formula for it, or I deleted it because I couldn't figure out a formula for it. Isn't this supposed to be a trig sub something? Like when you, okay, if you're doing that face, I deleted it. Okay, that one's deleted. It's not because of infinity. It's because of this thing. Because it's basically like 1 over cosine. So I think it's tangent or something. But we're not going to deal with that. We ain't got the time for that. Okay, if I can't see it, then we got to keep moving. The only exception is the cosine and sine squared formulas. Like there's definitely that on there. We've done that 100 times. Definitely have that formula for sure. Okay, this one's on there for sure. But again, that's the easy stuff, right? That's just a basic triple integral. This one's on there. Yet again, not too bad. The top is this slicey thing, this z thingy. So you solve for z. And then the bottom would be 0 essentially. So just triple integral stuff. You're not going to like it. You're not going to like it. This one's on there. Oh, it's on there. Were you here? Oh, you were here for that. Oh, you asked for it. It's terrible, isn't it? Yeah. It is a good question. I love it. It's my favorite question ever. But like here's a thought though. Because it's simply a triangular prism and it doesn't change, I think there might be a way to solve it generally, and there might be a formula even on Wikipedia, and you can put formulas down for triangular prisms. So it's a thought, like because they're only going to change the numbers, and it is a very standardized shape. I don't know it. I'm not going to advocate for it other than I've just recorded. But anyways, there are formulas for this kind of thing. If you